So yeah, my name is Thomas Amrein. I'm with Matti.
Yes, and my name is Martin, sorry. I forgot my script. Yeah, I'm Martin, and this is our title of the presentation.
So we would like to give you a very brief overview of our company, what we do. We have an approach to inkjet that we call the individualized standard. We're very hands-on guys, therefore we'd like to take you on a little journey how we execute a project that is coming from our customers. And then at the end we'll give you a little rundown of some success stories that you also see in what kind of a width that our modules that we have developed can be used. So at the end, we have a very broad set of modules that we can use to build inkjet machines. At the end, we put it in a very wide scope with sort of parameters that we focus on and that we consider when we build a machine. So we try to have an end-to-end ecosystem. We design and engineer our modules constantly, so that is a constant process, and we modify them also towards requirements of our customers. We basically see that our machines are very efficient, that have a very good uptimes. We have a considerable amount of engineering we put into automation to keep the machine healthy. We also log a lot of data for predictive maintenance. At the end, we focus very heavily on user experience, so we want operators to love our machines, to have a joyful working experience with our machines. And of course, we get confronted a lot with sustainability issues. We have a lot of investment we do in sustainable machines, in material optimized machines, and at the end, we engineer our components to be valid today, but also in the future. So we try to anticipate the trends that are coming up, and with these trends, we try to adopt these as early as possible into the modules that we use for our machines.
Yeah, as you can see, this is me. I work in the flexible industry and looking for a solution with a width of 1300 millimeters. I have a lot of short runs and customers with special or individualized designs, and I do not find a solution off the shelf. What can I do? Oh, I have a business card. I call Mr. Builder.
Yeah, so that's exactly how it starts. A customer looking for a special requirement, and Mr. Builder, myself, has a lot of experience, a lot of modules to use to cover those requirements that Mr. Flexible has for his flexible packaging machine. So I will try to see exactly what he is looking for. And therefore, I will get all the requirements from him. Mr. Flexible, what exactly are you looking for? We're happy to help, but we need to know exactly what you require.
Then I think I will send over to you my requirement documents.
Oh yeah, that's perfect. That's very good. Send that over, yeah, please. Okay, I see that Mr. Flexible has a lot of requirements. I think a lot we can cover with our standard modules. But on the other hand, I also see that he has some requirements that are non-standard. He is investing quite a substantial amount of money. And I want him to succeed with his project, and therefore, I think the best thing is to do get some de-risking via our lab tests.
Thank you, that's a good idea. I think we should start with a proof of concept.
Yes, perfect. I'll get all those inks that I think are possible for this project. I'll start off with the drop watcher. I will get the perfect waveforms. I will try to run those inks on our lab setup. I will generate some samples for Mr. Flexible. I think he's pretty happy with those. But I have identified some risks that we need to consider more deeply. I will hand over a report to him. Here you go.
Thank you.
Very detailed report, and I think we do have a lot of ideas that we can implement out of the box, but we need to consider some points. Please have a look at that and get back to me how we can proceed.
Yeah, thank you. Wow, you have done a lot of work, and that's very helpful. Your proposal looks suitable and capable to what I need.
Great. Okay. Then how can we proceed?
Yeah, I think that's a great concept. I can give you green light to go ahead. Here is the signed specification and contract. Let's go and build the system.
Thank you very much. Okay, let's go. So that's where we start taking our modules, building a machine, going into some more process engineering in the lab, and that is also where it can happen that we say, oh, some new components have become available. We see some substantial benefits using those components, and we would then revert back to Mr. Flexible to see if and how we could accommodate those components. So Mr. Flexible, we have seen that we can optimize some drying. We have found new components that would work very well. Would you like to proceed?
What exactly can you improve?
Well, we can improve the drying efficiency for your machine, and you will save a lot of energy.
Okay, and does this have an impact on my timeline and costs?
No, absolutely not. It's new components that we can use. It fits into the timeline, and there is no additional cost, so it should be a no-brainer.
Okay, sounds good. Go ahead.
Great. Okay, I think we have worked a lot and hard for this machine. We have kept all the milestones. The machine is performing as expected. Mr. Builder is very happy, has invited Mr. Flexible to the factory to see what he has to say.
Yeah, it's me again after my morning yoga session. And yeah, that looks great. Mr. Builder has kept all milestones, and I'm really impressed to see the machine that you built for me. Thank you very much for the great work.
Well, you're very welcome,
and
always.
By the way, that's a promise. We are much better engineers than actors.
Yeah. So yeah, Martin is right. But we just very briefly, we have some success stories that we can show you, because I think it's important and interesting to know in what kind of applications these machines can be used. So we have a very small test stand that we use for flooring manufacturers, for ink manufacturers. It has a specialty. It can move its print heads. It is always in register. It has an encoder built into the conveyor. Can be added with more colors. It can have different dryers. and so on. So that is a very interesting machine that we have built for a few of the flooring partners that we are working heavily with. On the other hand, we use our modules to build fuel cell machines, production machines. Sounds a bit off topic when we say we are a single pass company, but at the end, what we do here is we are unwinding, we're die cutting, we're printing gaskets with inkjet, some functional fluids. So we have a lot of points that really fit in and tie in nicely with all this modular setup that we have. On the other hand, we have some specialty projects. So always when other integrators say, oh, it's not possible, then we will normally find a solution. We always say it must be within the limits of physics. We're working on that deal, but we haven't got it yet. So if it's in the limits of physics, I think we always find a solution. Maybe it's not an economical solution, but technically it'll work. If it's not economic, then the project will not move ahead. But of course, we try to balance both, but not always easy. We build a lot of machines for OEM customers, such as Xerox for a long time. We've been working many years with Xerox. With Impica, we've worked a lot. And of course, we have our own portfolio that we are building, selling worldwide. So yeah, that was all. Thank you very much.
Thank you very much.
A slightly different approach. Thank you.